Okay, so today we're going to be talking about chords in circles. So if you have a circle, this is an example of a chord. So on these chords, if the chord is the same distance away from the center, so both of those chords are 5 units away from the center, that means those two chords equal each other. So notice just that little part is 7, so that means both parts would be 7, and 7 plus 7 is 14. So each of those chords would be 14. So on the next one, the two chords are equal each other, so that means they're the same distance away from the center. So since that's 7 away from the center, that means x would also be 7. On this one, notice the two chords are the same distance away from the center, so that means they equal each other. So what would the entire length of that chord be? That is going to be what x is. So 25 plus 25, that's going to give you that chord. And then this one, those two chords are equal, so that means they are the same distance away from the center. So if this distance is 8, that means x would also be 8. On this one, all the way around a circle is 360. So you will do 360 minus the 70 right here, and that would give you 290. These two, since these two chords equal each other, that means those two arcs equal each other. So just divide that by 2, and that will give you x. On these, since the two arcs are equal, that means the two chords are equal. So just put them equal to each other and solve for x. Same with this one, since the two arcs are equal, the two chords would be equal. So 3x plus 2 equals 5x minus 7, and then solve for x. This one, since the two chords are equal, then that means the two arcs are equal. So if that arc is 79, x would also be 79. This one, the two chords are equal, so that means the arcs are equal. So just put them equal to each other and solve for x. Same with the next one, just put them equal to each other. Solve for x. Same with this one, put them equal to each other and solve for x. I think, and then same with this one, put them equal to each other, solve for x, put them equal to each other, equal to each other. They're all mostly equal to each other. Okay, so these are the more difficult ones. So you're going to have Pythagorean theorem for the rest of the assignment. Your goal is to find x, so you're going to look for your right triangle. Now, this right here is going to cut those chords in half, so that's going to make this part 8, and then this part would be 10. So if I redraw that triangle in here, this would be 10, this would be 8, and I have to figure out x. So I know the hypotenuse. If you know the hypotenuse, you subtract under the square root. So you have to do the square root symbol, and then 10 squared, always the bigger number, minus the smaller number. 10 squared minus 8 squared. Now on the ones where you don't already have a triangle, you need to create a triangle. So you can redraw a radius anywhere in a circle and create a triangle. So I would just redraw it right there and create that triangle. Let me fix this. Okay, so I would redraw it right here, create that triangle, which would make that length 4. I do not know the hypotenuse, so I would add 4 squared plus 3.6 squared under the square root. Okay, the next one, we have a triangle, but on this one, when we solve, we're only going to find that piece of of the triangle, so you're going to have to multiply that by 2 to get the full length of that chord. So first let me look at the right triangle. I know the hypotenuse, so I would subtract 6 squared minus 4 squared. You're going to get that answer. You're going to have to toggle it. Take that answer times 2, and that would be the full chord. Because when you find x, it's only the bottom of that triangle. Okay, if you don't have a triangle, remember, you have to create it. So I'm going to redraw that radius right here and call that x. So here's my right triangle. So do you see how that whole chord's 22? The bottom of my triangle will be 11, half of 22. I don't know the hypotenuse, so I would add 11 squared plus 6 squared under the square root. And then this one, I've got my right triangle. I know the hypotenuse, so I would subtract and then solve for x. This one, you also know the hypotenuse, so you would subtract 12 squared minus 6 squared, but again, that's only going to be that bottom half of that chord. So make sure you multiply that answer by 2 to get the full chord. On this one, you know the hypotenuse, and the bottom of that triangle would be 4. So you know the hypotenuse, you would subtract 5 squared minus 4 squared. This one, redraw the radius. I will find the bottom of the triangle, so again, you'll have to times it by 2. You know the hypotenuse, so subtract, and then multiply that answer times 2 to get the whole chord. And this one, if this radius is 6, that means this radius is 6 because all the radii in a circle are the same. So we do not know the hypotenuse, so you would add 6 squared plus 6 squared. This one you do not know the hypotenuse, so add 5 squared plus 12 squared. This one you know the hypotenuse, so subtract 10 squared minus 6 squared, and then you'll have to times it by 2. You know the hypotenuse, so subtract again. You know the hypotenuse, so subtract again. So this one looks kind of weird, but this would be 17.1. So it's 19 squared minus 17.1 squared. So if you have any questions, let me know.